What is dark matter and dark energy? They make up the majority of the universe, but they are still a mysterious part of space science. In the following video, I would like to introduce what scientists have explored about dark matter and dark energy, and how they affect the fate of the universe. Dark matter is an undetected form of mass emitting little or no light, but though it exists, we infer from its gravitational influence. The compositions of dark matter could be ordinary dark matter, which are massive comparable objects, or baryonic matter that make up of atoms. However, scientists generally believe that most of the dark matter are extraordinary dark matter, which are weakly interacting massive particles or non-baryonic materials. Materials that are not made up of atoms, such as black holes, electrons, neutrons, and engines. The existence of dark matter could be proved by the following methods. First, we may predict the mass distributions of dark matter from rotation curve. Let's look at the rotation curve of solar system. As you can see, the curve aligns with the mean distance from Sun. According to Kepler's law, the square of period is proportional to the cube or the astronomical unit, so the further the planet from Sun, the lower of its orbital speed. Now, let's take a look at the rotation curve of Milky Way. The curve stays flat along the mean distance. In the Milky Way, if stars don't represent all the mass in the galaxy, then the missing mass may be dark matter. The second method is measuring the rotation curve by dipole shift using 21 cm lines of atomic hydrogen, which are called redshifts. In the absorption spectrum, you can see that there are colors missing in different dipole shifts. The third method is measuring temperature of hot gas emitted by X-ray from crystals. The last method is using gravitational lensing. Can you see the string rings and arcs of light, the sparkling pink areas? It is explained that the gravitational field of a massive object bends light waves passing close to the object. So, what is the relationship between dark energy and dark matter? Let's learn about the definition of dark energy first. A hypothetical energy component with negative pressure results in the accelerating expansion of the universe. Dark matter pools get together, forming photogalactic clouds and triggering galaxy formation. Dark energy acts as an opposing force to gravity and leads to the accelerating expansion of the universe. How about our universe in nowadays? Look at this pie chart. Nearly 75% of the matter is dark energy, 25% is dark matter, and only 5% is normal matter. With much dark energy, less dark matter, the rate of the accelerations of the expansion would increase. But how can we know what is going on? By calculating the mass density of the universe. The ratio of current density of the universe to critical density. The equations of critical density is this, which is similar to 1.06 times 10 power of negative 29. The density of universe is just mass over volume of itself. If the ratio is larger than 1, the expansion is decelerating. The universe will even collapse. If the ratio is smaller than 1, the expansion is accelerating. That's all we know about dark matter and dark energy, only theories and simple observations. It's quite frustrating, but it's also exciting. There are still so many things for us to explore. That's all for my videos. Thank you.